Good evening, sir.
Good evening. How are
Welcome
you?
to the session.
Good,
I'm
good.
fine, sir.
Sir, please be patient and wait for a while. We are going live on YouTube
Yeah,
for the
yeah, yeah.
session.
No problem. No problem. No problem.
So we will start shortly from 7 p.m. So if you would like to talk about something until then, you can.
Sir, your mic is mute, sir. Please unmute.
Yeah. So what I sent an email that what I plan to talk about is net zero is already done. Entrepreneurship is already done. So basically, I'll open the floor for any question on net zero, entrepreneurship, career, or startup, or anything. So I will keep my format very, very open. That's what my plan is. Okay.
Yes, sir. Yes, sir.
Yes, sir. Excuse me, sir.
Yes.
Sir, before the meeting start, webinar start, can you please tell me what is the flow of question that we were asked to you? Like,
Flow of question will be right from beginning. I will, in fact, ask some questions to the students, and I expect them to be answering those questions. So, flow of the question right from beginning. You can ask questions.
okay, sir.
Make sense?
Yes, sir. So, can you please tell me about your how's your college life?
My college life. Okay. One of the best time in my life was my college life. I had a great time in BIT because that's the time you make the bonds, you make friends, and that I still cherish after 45 years of my graduation. I still cherish that life in college. So my audio and video is okay.
Yes, sir.
Yes, sir. It's fine.
So, did you have any kind of suggestions or the extraction of your 4 years of journey, your college life? Because we are freshers. Did you have any?
The suggestion is that two things you have to focus on. Do your best in your studies, but at the same time, this is the time to generate relationship with your friends that will remain for your life. So if you focus on your studies and you make sure that you get good grades and good depth of the subjects, that will take you really very high in your career because of that. But at the same time, the strong base of networking where you can rely on your friends whenever you need is the one of the best part in the life.
Okay, so
So on a Google, on a YouTube, when it starts, it will show up in the live, right?
yes, sir.
Okay. Okay. So Komal and Karthik, to both of you, I think we talked earlier. And
Yes, sir.
any question you have from that time, anything new you're finding? The only thing new today is that I will capture broader topic, not just net zero, because net zero was already covered. And I will ask some questions on net zero about the understanding of students. So when I ask question, feel free to answer from your side also. You don't have to just look at the YouTube. You can answer from your side also what you understood from the net zero up till now.
Absolutely,
Yes,
sir.
sir.
Okay. So Karthik, you are from first year, you said,
No, sir. I am from second year.
and Komal, you are from.
Sir, I am also from second year.
Okay, so you're not a fresher. Okay. And one more thing, while you're listening, you can smile and you can laugh or whatever. Means you don't have to be so serious. I have seen yesterday or someone. I briefly saw that uh, let's see, students are very serious. You don't have to. It's an informal chit chat. Feel free to ask question. And I think you are once you become alumni, you are my brothers and sisters. Right now, you are students, but so our relation in the life will be brothers and sisters. So how you interact in the family, do same thing. Okay, don't have to be serious.
Yes, sir, definitely, sir.
And I may not have all the answers. So if I don't have answers, I'll mention that I'll come back, give the answers to the organizers who will pass on back to you, or we may have another short session to answer the questions because I don't know everything. You may, but I don't. I'm still learning.
So, sir, we are now starting the webinar because we have gone live for that. We are online. Good evening, everyone joining us in this live stream on YouTube. Welcome to our webinar, Pathways to Net Zero Strategies, Challenges, and Innovations in Achieving Emissions Neutrality, hosted by Quimica, the Chemical Engineering Society of BIT Sindri. I am Komal, your host for today.
And I am Karthik Kumar. Now, let's get ready for an inspiring session. Today, we are delighted to have with us Mr. Prafull Kumar sir, President at Realized LLC and Executive Leadership Coach and Career Guide all over the global. Welcome, sir. Let me share something even more captivating. He is a HBTI Kanpur University alumnus. He is also an experienced principal project manager at KBR Incorporated in Texas.
He has immense experience while working in major organizations such as Principal Process Engineer at UHD, GmbH, and Project Engineer at PDIL.
Let's applaud Mr. Prafull achievements, spanning various specialists as we delve into pathways to net zero strategies, challenges, and innovations in achieving emissions neutrality. A warm virtual welcome to Mr. Prafull, sir. Over to you, sir.
Namaskar to all my brothers and sisters. I'm very happy to be here. And this is my privilege or prerogative or all the, you can think about how happy I am today to talking to the young students with whom I'm going to interact and learn also. So briefly, I'll just mention about myself also, and you can start the slideshow also, Karthik. So I started in BIT Sindri in 1972. I joined in chemical engineering, and the life in those days were quite different compared to today. We didn't had any social media, we didn't had anything. The only entertainment we had was going to movies in Jharia and Dhanbad or going to Shahrapura and eating something. So I come from that background where studies and reinventing our friendship every day and making our bonding stronger and stronger every day was the main focus. So I come from that background. After I finished my education, I did my master's, as Karthik just mentioned. After master's, I joined PDIL and I came back to Sindri. I stayed for almost like 8 years in Sindri working in P&D. From there, I went to a multinational company, Uday, in Bombay. And after a few years, I went to Houston, where I retired from KBR after working more than 30 years. And currently, I have my own company where I do the project management consulting. And I also work with all the students and the alumni all over globe. So this is my current background. I'm currently speaking from Philadelphia in the US, and I reside in US, and I keep coming to India. And even last year, I was in November when we had a 50th year of Golden Jubilee celebration for my batch. I'll tell you that coming back to BIT was very, very nostalgic. And it was not only for me, for my wife also, because we spent quite some time in Sindri. And coming back to BIT was like coming back to family. The love, respect, and the interaction we received from the students were very, very good. Miss great interaction with all of you. Miss, we felt at home, completely at home. So this is my humble background. I'm coming from this background, and currently I have almost like, if I'm not exaggerating, almost like 100 students I have interacted with in last 4 or 5 years. I'm mentoring them. I'm helping them in their job search, with group discussions or mock interview, or even personality development, communication, leadership, project management. All these things I'm working with students. And doing this really gives me a great pleasure that I'm connected and I'm doing something for my alma mater. So moving from this point to the today's topic, and today's topic, I'm keeping it very broad based because you had seminars, webinars, and lot of interaction in the last few days. And net zero topic is one of the very popular topic. That's why you are having twice, and it's partly already covered. So I will not be going in detail in the net zero, but I'll be broadening this to any question any one of you may have about chemical engineering related topic. So Karthik, can you start my PowerPoint?
Yes, sir. Can you, sir, can you please start, yeah, repeat again?
Can you start the PowerPoint presentation?
Okay, sir.
Yeah, please. So net zero was a topic which was covered to you, and I'll just briefly test the topic. So it's called net zero. Now, my question to all of you, and I will keep the floor open for question answer right from beginning. If you have a question, feel free to put your question in the YouTube, and that will be asked by Komal or Karthik. And I want to make it interactive. It's not just I'm speaking from this side and you are listening, but my topic is more of if you have any question on net zero or entrepreneurship or career development or personality development or project management or communication or leadership skills, any question, feel free to ask because I'm open to answer any question. Even if you have question on any other chemical engineering related topic, I'm open to for that also. So let's start with net zero. And let me ask you, what is your understanding? What did you understand from the webinar which you attended 2 days back on net zero? What it means to you? Net zero is the topic. So what it means to you, if you can answer. And let's see if you have any question coming, Karthik or Komal.
Absolutely, sir.
Because my aim is to work with your understanding and go from there. Okay.
Yes, sir.
So no one understood anything?
So, sir, can
So,
we start with the presentation?
Yeah, sure.
Okay, sir.
And I don't have access to YouTube, so I don't know what questions are being asked. So you have to manage that because I am not able to see the YouTube.
absolutely, sir.
So first slide, where my name is there, in the bottom of that first slide, you'll see that you have a uh, name of the company, Dream Realized. And if you go to dreamrealized.org, will tell you uh, the website address where you can interact with me. In fact, the website address, what you see in the slide is not the correct address, but that's what you need to connect with me. So any question or any answer, what you understand by net zero? go to the presentation mode on the slide. That will make it easier for people to see. So is anyone answering, Komal? Any answer you received?
So they are trying, but they are not able to answer it perfectly.
Okay, whatever answer is coming, just tell me few answers so that I will know that what is their understanding. Then I can explain more about it. So the
So,
word, when you hear net, what's the meaning of net when you hear in your life? Net something. And the second part is zero. What we want zero. Yeah, go ahead. You're
sir,
telling
here,
something.
net zero people or the audience saying net zero means the total is zero. Means when you compose
Yeah.
something, then it will be zero. Means the total product will be the zero.
Okay. So that's the math part. But for chemical engineering, we have to go beyond math. What are we zeroing? Our life, our education, our friendship. What is net zero?
So basically, it is cutting off the greenhouse gases. We are trying to reduce the greenhouse gases, which is eliminating as much as possible.
Perfect. Perfect. That's perfect answer.
Sir, I am Dr.
So we.
Nirupma.
Oh, welcome, Dr.
Okay,
Nirupma.
sir.
I'm honored to
Okay.
be talking to you. I think you are the faculty in BIT, right?
Yeah, yes, sir. Yes, sir. We just
Perfect.
joined 2 years back.
Very good. Very good.
Okay, sir.
We are so happy to have you as a faculty. So welcome.
Okay, thank
So
you, sir.
you brought a good point. So we are trying to have a greenhouse gases net zero. It means right now we are not net zero. And if we are not net zero, then what is happening? So you can continue on the slide. I think this is the first slide. If you can go further down, can you go to this? Forget my introduction. Continue going. Yeah, please continue. One more. So these are the services I offer through my company, and this is free, as I mentioned before slide, for any alumni or any student. If you want to take advantage, you can take it. Yeah, let's go to the next one, please. Yeah, so basically what we are trying to do is to achieve net zero, means whatever we pollute, we take it back from the environment, then we'll achieve the net zero. It means right now we are not net zero. Indirectly, it clearly says it means we are not net zero, and we have a plan which most of the countries they are talking by 2050 they will arrive net zero. So basically, what are the steps they are taking to arrive to net zero? And this was also very well discussed in your last webinar. They talked about some of the steps they want to take, and that's how we'll achieve net zero. So if you can tell me at least one step which you got from that webinar, that will be great. I want to hear from you that what did you catch from the webinar, that what should we doing in even in a personal life or professional life or anywhere. This is a collective action of all of us. And if you pay attention to the slide, there are a lot of things on the slides also. Let's go to the next slide and see what answer comes. What can we do as an individual or collective professional or as employee, as a country, as a society? What all we can do? And Karthik and Koval, you can also answer. Like Dr. Nirupma, she answered. You both are also, feel free to answer. What did you catch from that webinar?
So, as you asked, that as a public or as a person, citizen of a country, what we can do to achieve net zero, one of our audience
Mhm.
answered that we can use some public transport instead of using personal vehicles that can reduce the emissions of carbon emission.
Perfect. I really like. But are you using a personal vehicle? If I'm not using personal vehicle, then this theory has no meaning for me. And I'll give you example. Like in the US, I'm here in the US. You will find that most of the people in USA will be single person in the car, not a passenger with him. Most of them are driving alone. So it is applicable to those people who are driving alone to office. And I'll give you another example for myself, what I did. So what we have in US, and I think it's happening in India too, that if you have more than one person in your vehicle, then you're allowed to have access to a certain lane on the highway, which is called HOV, high occupancy vehicle lane. And certain time they allow with one person extra, and certain times when it's the peak time, they allow two-person extra other than the driver. I did my entire life carpooling, which is called carpooling. We were carpooling three people together to reduce the emission. Otherwise, we'll be driving three different cars. But instead of driving three different cars, we were driving just in one car, three people, so that one third emission is there instead of three times of that. So that's good. But are you driving every day? If you're not, then tell me what you are going to do. That theory is good, but I'm looking for what you are going to do, all of you. What is your commitment to do net zero?
So, we can take small initiatives in our daily life basis that we can reduce the carbon emissions as being a citizen of the country. And if someone is the if it is a company or employable person, they can just ensure that the company is following the protocols that should be followed to reduce the carbon emissions and pollutants in the environment.
Good, very good. But give me an example, your personal example, what you will do. This is good theory, but I'm asking practically what you can do today.
There is one more example, like the coal we use for the daily basis for the preparation of food. The like in our hostels, lots of students going to eat food every day with three times a day. A lot of coals were used for preparing a food. Instead of using that particular amount of coal, we will decompose the waste and generate the amount of energy and prepare a food from the particular source. Is also a live example of this.
So, Karthik, are you familiar that I'm from BITSA International? I'm the president of BITSA International also. And we have supported a startup in BIT where we supported a biogas plant where from the waste of a hostel, we produced biogas, and that biogas is going to be used in the hostel for cooking the food. Are you familiar of that project?
Yes, sir. Yes, sir. I am quite familiar with it because I am living at hostel number 26, and the thing which you are talking about is just behind the particular hostel, and
Okay. So
we just
can you
set up.
make sure that that biogas plant is operational, and we are not using coal, but we are using the waste gas coming from the biogas plant, and that is being used in the hostel? Personally, you can do that because that is in your hostel. So make sure that biogas plant is in use, and you are reducing the footprint of carbon by not burning coal. You have a very good point. I totally agree with you. Very good. Anybody else? Let's go to the next slide. And there are some more hints are there. What can you do? Unless we find something we can do, these webinars has no meaning, right? And how many people are there listening, Komal?
So it's almost 80 to 100 and it is still counting on.
Okay. So these 100 people, suppose everyone takes a vow that I am going to do something personally in my capacity and I'll practice it. Because what I'm looking for is net zero in your attitude, that you're not just coming and listening webinar and walking away and have nothing to practice in your life. I'm looking for something you can practice daily and make a change. As Mahatma Gandhi said, if you want to change, change has to start from you, right? So I want to hear from all of you what change you are making if you want to change the world. So no one is saying anything on the YouTube, no other answers.
So audience are giving answers. Like some
Yeah.
of them are writing that we can reduce the excessive use of electricity and water. That that means the
Okay.
misuse of electricity and water in daily life.
Okay. Give me example how you can reduce use of electricity in your daily life. What is the example?
So we can reduce the number of lights during the daytime as we can have the natural light.
Okay,
Instead
good.
of using that electricity, we can use the natural light. And if not necessary, we should not use a lot of electrical appliances. Like if we are moving out of the room, we should switch off the fans and lights so that we can save a little bit electricity from our side.
And same thing
And
for water, because generating drinking water consumes electricity or consumes power. And if we don't waste water, then definitely that will save some water energy and some CO2 emission. You're telling something, Karthik. Go ahead.
yes, sir. For the shake of water, just in our BIT Sindri, there are lots of hostels which have their personal solar panels where we use electricity, where we produce electricity with it. So if we produce electricity from the solar panel, so sir, with this the excessive use of water will quite cut off, so that uh, we can save our water too.
True, true. Absolutely, absolutely. I totally agree. Okay, let's move on to the next slide, please. So this slide is talking how the aviation energy or aviation companies are going to reduce the carbon emission by 2050, and they're giving some recipe how they want to do it. So this I brought as example where you can see that everyone is trying to do something, and that's the reason I'm trying to bring this home to all the students, that we all can contribute. It's not just listening a webinar and walking away and oh yeah, he said something. No, we all have part to play. And same way, I'm just showing a industry wide plan how aviation industry is going to reduce. So what you see in this slide, that their aim is by 2050, the 65% sustainable aviation fuel they will be using. Then 13% they are going to use new technology, which is electric and hydrogen. How many of you are familiar that testing of hydrogen fuel airplane or electric airplanes are already happening in a very large number? How many of you are familiar, or any experience or anything you have heard about this electric plane or hydrogen fueled plane, and how far they are going, where the testing is happening, and how far they are going. What is the uh, chances of commercialization this in next 5 years? Can someone tell me?
Yeah, I think audience might not have little knowledge about the topic, so it would be good if you will explain about that.
Okay, okay. Any other answer, or this is the only answer you got?
So they don't seem to have a better answer or answer to the question that you have asked. So please explain the topic so that they can have a better understanding over that.
Okay, okay. So what's happening that currently the testing of airplanes are happening based on hydrogen fuel and the battery operated, and even the plane which will take off based on battery, and then they have a solar power, and they can solar panels that they can continue running. These three testings are being done at this moment. If I tell you based on the current data which just happened recently, the planes are able to fly up to 900 miles in one charge of hydrogen fuel or the battery. So if I say 900 miles, and if you check the flights, what's happening in India, means that's more than an hour flight. And majority of flights are happening hour and a half. So if we commercialize today those planes, that will take a lot of CO2 away from the emission. So that's called reduction of fuel. Sustainable fuel is also being tested, and that's also happening in big way. Okay, let's talk about this third point. 3% will be reduced by efficiencies. So I hope you all are familiar with refinery. If we make our refinery efficient, how much energy we can save in your previous webinar also, in your previous webinar also, that's why I'm asking. No, no answer.
So audience don't seem to be familiar with the topic. So
Okay,
please.
then I'll bring the familiarity. So in a refinery, there are several units, and like for let's take the simplest example. What he meant. We have a vacuum and atmospheric distillation. Remember, you have studied in refineries these units. So vacuum and distillation unit is the unit where we bring the crude oil and we get our different products like aviation fuel or regular gasoline or kerosene, and all those things we get from that atmospheric and vacuum unit. If we improve the efficiency of that tower, and I think the webinar host mentioned that if we design our distillation column with higher efficiency trays, or if we design our reboiler with a better efficiency heat exchanger there, or condenser, if we improve the efficiency of that tower by insulating it properly, lot of energy is going to be saved. And if you save that energy, what are you saving? You are saving the CO2 emission. So when they talk of efficiencies, means there are a lot of scope where we can improve the efficiency in our process industry and save the emission. Okay. And the last point he talks in the slide is 19% offset by carbon capture. So this was also quite a bit discussed in your group. Carbon capture was basically you have a good understanding of that based on your last webinar. So I'll just leave it at this point and move to the next slide. Let's go to the next slide, Karthik. So the next slide will show you all those temperatures, what he mentioned, 1.5 degree, 2.5 degree, and all those things. And basically, these are the temperatures showing you how things can be uh, planned and implemented. So 1.5 degree, he talked about that. That's what we are trying. And we are trying to achieve that by 2050. We will have our emissions under control so that we are net zero. But let's talk about the concept of net zero, means, how we'll achieve. So number one, what we talked about, reduce use of fossil fuel by efficient process. I just talked about how we can improve our efficiency in refinery, petrochemicals, or any chemical industry or plastics or any, or even the steel industry or any industry. If we improve the efficiency, basically the CO2 emission goes down. So to achieve net zero, first thing is to improve the efficiency, right? And here, chemical engineers are very much required. This question was asked that how chemical engineers can do it. As I mentioned, that any process plant, when you design, when you do the simulation, when you do the design of equipment, make sure that your design is achieving the high efficiency to reduce the emission. And think about it. When you reduce the emission, what happens? If you have a very high or efficient refinery, you will produce your products at cheaper price because your efficiency is high and you're producing your gasoline at cheaper rate. And others are not able to do that. So in market, you are going to achieve a higher profit and your company will have a more profit, means you'll get more bonus and you will have all good life and everything. So this is not just going to give you a net zero, but this is also going to give you what you want to achieve in your life. So that's why when we say improving efficiency is not just for your employer, you are trying to do it, but when he makes high profit, he will be sharing with the employees and he will be opening more refineries and more employment and everything. So that is most important where all of us comes in play. We have our responsibility and we can take care of that. Let's move to the next slide, please. And as I have mentioned, I'm open for question anytime. So if you see any question relevant, please feel free to ask me, okay? And I'm going to
Definitely.
go,
Yes.
go ahead. Karthik, you wanted to ask anything?
No, sir. Sir, out of
Okay.
contest, audience, one of the audience were asked one question, like, as a citizen of a developing country, which has billions of massive, what difference think we can do to approach our goal of 2070 along with good GDP growth rate?
Okay. So this is not just technical question. This is a technical, political, and a lot of things are loaded question. As you may have heard that when India was asked to meet the net zero by 2050, India clearly said that I cannot do it. because our main infrastructure is there to produce energy or electricity by burning coal, and our alternatives are not there. So India requested USA that USA needs to give India the nuclear power technology so that they can convert our thermal power plant or coal based plants to nuclear plant which has no CO2 emission, and that way we can reach net zero. So the negotiations are there. You may have seen, I don't know how many of you research on this, but if you go and research that how many nuclear power plants are coming in India, there are a lot. There are many nuclear power plants are coming, and chances of reducing coal is there. But coal is not just used in the thermal power plant. In India, coal is also used by many houses in the rural area, burning coal, burning wood. These things are also quite prevalent. So we need to provide them alternative source of energy so that entire country can move away from burning coal and burning wood. So as a developing country, India needs to implement those technologies which can alternatively produce electricity. Let me bring up an absolutely new topic here. I don't know how much you know about this. When I talk of nuclear, there are a lot of things to talk in nuclear also, and chemical engineers are quite versatile. I have many friends who, after doing engineering, they went to BARC and they became nuclear engineer after the training. So, how many of you know about a nuclear fission and nuclear fusion? Anyone can talk? And Dr. Nirupma, you can also jump in anytime you want to join. So these questions are open for anyone. Nuclear fusion and nuclear fission.
So, nuclear fission and nuclear fusion both are utilized for producing energy. Difference is that
Good.
in fission, the atoms break down to produce energy, and in fusion, the atoms collide to produce energy.
Very good. I'm very impressed. Okay. Do you know any power plant in the world which is producing energy based on nuclear fusion?
No, sir, not about fusion, but I know fission, the
Yeah,
power
that
plant.
is happening. And that's what is, when I said nuclear power plant, most of them are nuclear power plant based on nuclear fission. And so let me bring you up to the speed, which is a new technology. If you pay attention, there are major players in the world. And I know a very large startup also, one of my friends, large startup. They are trying to produce nuclear fusion. The nuclear fusion is the same energy source which sun produces their energy and provides us this limitless energy. If I predict, then the way all the researches are going on, this nuclear fusion may come in commercial production in next 5 to 10 years. The first uh, plant started, I think, last week, if I'm not mistaken. Last week, the first plant started in Japan, where Japan and Europe they combined together, and with some MIT graduates helping them, they started producing on test bed. So one of the biggest challenge of nuclear fusion is that it needs a lot of energy to start the reaction. So all the research going on up till now, miss, they were not able to produce. Miss, suppose you have to put uh, trillion gigajoules energy to start the reaction, and then you produce half a billion or a billion gigajoules energy to sustain that. That's not the way we want. We want, once we start this fusion, it should give me surplus energy. And this is the first plant in Japan. They started producing that. It is a very expensive unit. This is a very expensive unit, and definitely it will be uh, multi-country. It's not single country can do this. It's a multiple country joint venture. It can be done. But once we have that proven system ready, then nuclear fusion have no emission, no CO2, and there's nothing in nuclear fusion which you have to worry about. So net zero, you don't have to worry about it at all. There's no CO2 in that, and there is no radiation issue. But just to give you idea, uh, the temperature at what the nuclear fusion happens is almost like a million degree centigrade. Let me just say million as a M, million degree centigrade, this reaction happens. And the reaction they are trying to do, they are taking two hydrogen atoms, and the nuclei they are combining, where they create a helium, and that's a mass is reduced, and that mass is converted to energy, and that's a huge amount of energy. Once we have proven this in nuclear fusion, there's nothing else to worry about. So I just wanted to give a side story. So how much I'm making sense, or how much you understood? Can someone give me once or one or two lines just to give idea that yes, something I said and you understood? Anyone?
Yes, sir. You talked about how the nuclear fusion can be utilized, and it will have net zero emissions of carbon when it will be achieved.
Not even net zero. It will be no emission. There's no CO2 produced in that. So based on that, you have to no CO2 produced, and you have a limitless energy once we have the commercial production of that plant. Okay.
Yes.
Hello, sir.
Any question on nuclear fusion?
Hello, sir.
Yes, sir.
Is there any safety issues also associated with this nuclear power plant? Like in India, also there are so many people are protesting for this nuclear power plant.
Absolutely, Dr. Nirupma. The Kalpakkam plant, which was built in
Yeah.
Chennai,
Yes, sir.
the key issue is that this is a nuclear fission
Mm-hmm.
where you have a heavy water and you have a radiation, and a Chernobyl accident happened, and this and that. So nuclear fission, which we are trying to do right now,
Mm-hmm.
has a potential for radiation. So people who are
Okay.
living around these plants, they are worried about radiation. And yes, nuclear fission has that issue. But
Okay.
the good news for nuclear fusion, there's no such issue.
Okay. So this is going to be safer.
Yes, yes.
Okay. That's a good achievement if they
That's the
were
best
looking for.
achievement. You will not
Yes,
believe
sir.
that I'm also following this particular thing, and
Mm-hmm.
I have a friend who has a startup, so I get the inside story that how they are starting and what they are doing, and I'm quite involved in nuclear fusion.
Okay, so really, sir, it is very interesting, and this world is also needing this type of research. Also, you can say.
Absolutely, absolutely.
Mm.
And chemical engineers are very much required for this new technology to commercialize.
Yes, sir. Even in India, also so many states are under like these are really polluted. Like you can't sustain in like Delhi or in Bihar. It is
Yeah,
the level of this thing is day by day increasing.
true, true. When I come to India, I live in Dehradun. In between Dehradun and Masuri, there is a place I live.
Yes,
And
sir.
where I live, I can tell you that a lot of people from Delhi, they just escape even for the weekend, so that the Friday night they come and they can stay and breathe fresh air, because the AQI for that place is very same as where I live in Houston. Their AQI is same as where Dehradun I live. So a lot of people they come and stay in the weekend and then they go back or whatever time permits, because pollution is creating so much of your health issues that your lively longevity is really going down. But we'll not derail the topic. We'll continue on the fusion. So yes, that's true. Any question coming, Karthik or Komal, on fusion, or am I speaking something very high tech?
No, sir.
No, sir. You are just talking about the general day-to-day life scenarios, and the audience are
Okay,
understanding well.
perfect. I'm very happy. This, to tell you very frankly, I'm also learning this fusion technology. So it's something really, really current. You can imagine that only last week this Japanese fusion plant came in action and they are producing energy. So I'm just talking even today's news, what's happening in the world. Okay, let's go back to my slide. So I was on this slide where we were talking about CCS, which is carbon capture and sequestering CO2. And I think this was covered quite a bit. But what I want to bring up here, that there are three ways this is being done. One is biological, where biological means this is automatically it's happening. A lot of CO2 is absorbed in water, and especially in the cooler water on North Pole and South Pole where the water is cooler. So this is getting absorbed. And even the ground and a lot of, of course, greenhouse photosynthesis, you all know. So there are a lot of biological way this is getting captured, which was not covered in the last seminar. So let's move on to the next slide. And I'm giving you topics so that you can go and research yourself also. So the second part is geologically, and this was uh, partly captured. And I think he also mentioned about Texas, where I live, how this is being stored, transported, and stored. And yes, that's happening. So this is already covered. And he briefly covered about this technologically how recycling is happening. So a lot of things are being produced like methanol, graphene, and things like that. So technologically also it's being captured. And now in at least in US, they have a CO2 pipeline all over country. So the people who are producing CO2, they compress the CO2 and put in the pipeline for other industries to use it. Like if you have ammonia and you want to make a urea, you need to have CO2 so that you can produce urea. So other things are also happening. So I'll just leave it there. I'll move on. Next slide, please. So now we are here at the renewable energy processes has to be developed. I'll discuss a little bit more. But the top, we didn't talk. So I'll talk a little bit on green ammonia. Solar, I think you know. Wind energy, you know. Tidal, you know. Geothermal, you know. If anyone would like to know about these energy, how produced, feel free to ask question. Solar, wind, tidal, and geo, I think you all know. So I'll talk a little bit on green ammonia. So what they do, they get the green hydrogen, and green hydrogen, the challenge, I think he didn't capture on that, that the challenge there is that this hydrogen, how you transport. For transporting green hydrogen, you need to have high pressure. And the pressure, what we are talking is 300 to 400 bar. You're familiar with bar? Yeah, I think you're familiar with bar. So 400 atmosphere or bar, whatever is equivalent, close to that. that kind of pressure is required to transport in the pipeline, or you need to liquefy. And as you all familiar with LNG, similarly, if you liquefy hydrogen, that will be at around 253 degrees C. So it's a challenging issue. If you see in India, we are not able to transport LNG so freely and easily, and it's not easy to do that. So because of that challenges, technology are still being developed how to use green hydrogen. So that is one area for chemical engineers to focus on. That okay, I can produce green hydrogen, but how to use it? How to send other places? So one of the way is to produce green ammonia. So when you have a green hydrogen and CO2, as I mentioned, coming, sorry, not CO2, and you can take nitrogen from the atmosphere by using that, using a synthesis reactor, you can produce ammonia. Now, ammonia you can transport at minus 33 degrees C, which is not that difficult. And people are used to transport ammonia in a big way since long time. So we have experience, technology, and knowledge of this. So you may have heard that a lot of this shipping industry, they use uh, heavy oil for their energy needs. They are converting to green ammonia or ammonia fuel so that their energy or their emission becomes zero. So how we'll use ammonia as energy? Anyone knows? Or leave it. I'll leave this question for you. Research a little bit on green ammonia, how the shipping industry they're planning to use. And I'll move on and come back on some other issues also. So go to the next slide, please. Next slide. Okay, so this was already covered. What is green hydrogen? I will not talk about it. This is, already you discussed in that. And the different colors of, go to next slide. Different colors of hydrogen is also covered. You are familiar. If you have any question, feel free to ask. Keep going to the next slide. Okay, so these are how you produce green hydrogen, blue hydrogen, gray hydrogen, and basically these are the different hydrogen. He also talked about that, so I will just move on. So stay here. No, yeah, continue going further.
Excuse me, sir.
Sure.
Sir, as you have mentioned, or as you have asked one question from the audience side, that what is the use of ammonia, right? So, sir,
Mhm.
here is one answer from the audience side that shipping companies are exploring the use of green ammonia as a cleaner energy source to reduce environmental impact.
Absolutely. So when they have a green ammonia, they can use that ammonia as a source of energy, and then they will not be emitting CO2. So what they will be emitting? What will be the emission from green ammonia when they use in the ship? This is a question to the audience. Okay, and we'll move on. You'll get the answer, and then we'll move on. Go to the next slide. Next slide, please. Yeah, so this is how first time ammonia was produced, and we'll move on. This was discussed in your uh, previous webinar also. I'll move on to the next one. I'm a little bit looking at more schematic. Yeah, next slide. Okay, so this one as a source is showing that renewable energy sources are being used and they provide you the energy. Why we need energy? because we have abundant water source. And when we do the electrolysis of water, we get hydrogen and oxygen. That is stored in the Horton sphere and the other way of storing. Then you can see that we are transporting that hydrogen differently in different ways. And that's how we are distributing hydrogen to everyone to use it and reduce the emission. What happens? We are getting, oh, it's snowing outside. I'm just seeing from the window, the snow is coming. Nice, beautiful snow. Okay. So what's happening uh, means when you burn this hydrogen, the only emission is coming is water, and there's no CO2 or nothing. And we are taking a source as a solar or wind or all these or hydel or these natural sources, renewable sources we are taking. So we are not only eliminating complete source of CO2, we are also harnessing the energy in a cheaper way because solar, as someone mentioned, that it's there on your hostel, and you see that solar power, once you install it, God sun is giving that energy free of cost, right? So one time you have an initial cost and then you're getting that free energy. So this is how we are looking for harnessing that energy, whatever comes from the nature, and use that. That is still expensive right now because we are not commercializing that in a big way. The moment we start commercializing any technology in a big way, the cost will come down. So this green hydrogen, you will continue to listen. And let's move on to the next slide. I'll talk about a few other things also. So we talked about how we are going to use it. So you may have heard that hydrogen fueled car. We'll talk about how it works. Then we can go for this green hydrogen for green ammonia. In refinery, we can have a hydrogen network because refinery, we hydro treater and all those kind of units are using hydrogen. So we can use that for that unit. You may have heard green steel also. There is a proposal and there is one plant already built for green steel where they are using green hydrogen. And this hydrogen is there for any use without pollution, as we just discussed, right? So let's move on and talk about some fun stuff. So when you are driving this car, if you see in the side, it says that fuel cell. So this car is fueled by hydrogen. And to tell you, as a commercial vehicle, hydrogen powered cars are, I see them quite often on the road. This is not something we are talking as a lab or something. This is already commercially available and being used. So this technology is already popular, and the price of this technology or the price of fuel cell driven cars are going down and down as we speak. Same way as electric car is going down and down. So how fuel cell works? Anyone knows about fuel cell, how it works? Okay, this is also a technology being uh, tried since long time, and this is proven technology. What, can you go to that car picture, your slide? Yeah. So if you see that this car has a fuel tank, which is hydrogen tank, and then you pump hydrogen as a fuel, like you go to a gas station. Similarly, they have a hydrogen fueling station here in US. I've seen them. You go and pump hydrogen in the car, and then that car is operating on hydrogen. But what are the inner components? I just want to give you some idea that how they work. So the hydrogen goes to a fuel cell through fuel cell, it generates power. And with that power, there is a battery pack, which is uh, charged. And then combined, you have this operating car, which has a battery and a fuel cell both, which powers this car. And this is absolutely zero emission. And the second part, that this has no long term charging requirement on the charging station like electrical vehicle. So same technology, the reason I wanted to talk about this, same technology they are using in the airplane also. They are fueling that plane with this hydrogen. They have a fuel cell, they have a battery, and that's how the current technology, the planes which is being tested at this point, which can go up to 900 miles, which I said that it was tested recently, just last month, I think. It was tested in Germany. And so this technology, you need to understand well what fuel cell does, how it works, how it charges battery, and things like that. And chemical engineers will be very much required to commercialize fuel cell in a big way. The fuel cell is already commercialized, but there's a room for improvement, and we can make it more and more efficient. Okay, let's go to the next slide. How much time I have?
Excuse me, sir.
Sure,
Excuse me, sir.
sure, go ahead.
Sir, there are two answers from the audience side that as you asked from them that what is fuel cell and how fuel car work. Okay.
Fuel cell carbons, yeah.
So,
Mhm.
then our first answer is a fuel cell generate electricity through an electrochemical reaction between hydrogen and oxygen, typically from the air.
He straight went to Google and searched it. Yes, that's exact Google answer.
And the sir second one answer
Perfect.
is a fuel cell generate electricity through a chemical reaction between hydrogen and oxygen, producing water and releasing energy in the process.
True, but this anode and cathode, that's the way it's being done, and that is true. That's exactly, if you do fuel cell search on Google, that's the answer it comes. And this is a very, very interesting how air comes from, how oxygen comes from air, and how hydrogen comes from the fuel tank, and then they combine, and that fuel cell produces energy which directly goes to the battery. And it's very, very fascinating. When I read about this new technologies, I get excited. And one of the reason I get excited, because I've worked for 30 years in a technology company where we used to develop new technologies and we used to sell new technologies. And green hydrogen is one of the offering from my previous company, where we build green hydrogen plants all over the world. So these are very, very exciting things. Good. I'm very happy to get the answer. That's the correct answer. So let's, how much time I have? This, should I finish or should I continue?
So as you wish, you can continue.
Okay, let me see how much time? Oh, okay. So I already have more than an hour done. Okay. So I'll there are many other things I have here. Can you go on the slides? We talked about futuristic trend. So there were a few questions on data alchemy. That's the slide I am looking for. Keep
So
going down. Yeah, data alchemy. So this was one question, and I just wanted to introduce the topic. Data alchemy is basically, in a current process plant, we generate a lot of data through operation, through design, through maintenance. And all this data comes from different sensor, process control, and different simulation, and all those things. this data has not been brought to one place and it has not been utilized very efficiently. So this is one area where you can look into in future to do some work. Okay, so that's called data alchemy. Let's move to the next slide. I'm just touching the topic. I had a plan to talk in a little bit more detail. So here we talk about uh, second slide. I think just before that was a materials marvel. If I'm not mistaken, that's the next slide. If you can go up one slide. Yeah, materials marvel. So this is also an area where chemical engineers are going to be affected quite a bit. And just for example, I'll just take a simple example. When we talk of these chips, I'm not talking of potato chips. I'm talking of IC chips. So these semiconductor chips, there's so much of material science is coming in that area, and so much things are happening that lot of chemical engineers are also required in that area. To tell you even further, there's so much of new materials are coming that when we do the heat transfer calculation for heat exchanger or the properties of material for our calculations, a lot of things can be improved and changed. So we need to progress in this area. And the reason I'm going and giving you these different areas where the future is going to take you, so that if you have interest in that area, you can ask some questions and we can talk about today or even in future. We can talk about it and I can definitely work with you on these areas. Let's go to the next slide, please. Yes. So sustainable or circular economy, how when we produce our farming products, how we can use it. And again, we have a farming. So this is kind of, we recycle that, we redesign that, we manufacture, we retail, and then we reuse things. This is another area where our chemical engineering is very going to be useful, so that we can bring our economy less polluting and more user friendly, where we can get the better economy. Next slide, please. So digital gold rush, and I think digital gold rush is a lot of people talk about it. What's happening that because we are collecting so much of data, the security of data, how we can use that data is becoming a major issue everywhere. So how to keep it secured so that my data is not stolen and somebody else is building that technology and that company. That is a digital gold rush where people are trying to monetize the data. Is data security and data integration and things like that are happening all over the world. We need to be focusing in that area also, which is a very important area for chemical engineers. And I think the last slide is here, bioprocessing and biochemical. Uh, Recently, we had a G20 meeting. We all are familiar, right? We all had was that. In that, we talked about biodiesel. India really talked about biodiesel in that meeting. And this particular chemical engineering area or application of chemical engineering is coming in a bio area where we can use our agriculture products or animal fat or many other things we can use, which can generate the fuel. So we are not using fossil fuel, but we are using uh, some other source and trying to use it. But of course, when we create biodiesel, we have CO2 emission and things like that. So that may not be the best thing to do. But this is another area where we can reduce the emission. Now, as I mentioned in the beginning, that I will be able to answer any question on your career, your mentoring, your personality development, your communication improvement, leadership skill, your project management skill, or on net fuel or net zero, or even entrepreneurship. In fact, you may be familiar or may not be familiar. Right now, we are going to form groups of students who are interested in entrepreneurship. So these groups, they will come up with the idea what problem from society they want to solve, and they can create a startup based on that. So we are going to form several groups. If you are interested, please contact me, and we are starting at this point. Uh, our aim is that as you come up with a solution and you need a funding, we can provide you with the seed funding so that your startup can move on and go to the next phase. We are trying to have a competition where few of the selected ones will be funded at the end of 1 year as a startup company. And just to give you a background, as I mentioned that we funded that biogas startup few years back, and there we funded I think 12 lakhs rupees to get that plant completely built, and those were the students from BIT who did it. Recently, we are funding another startup which is in our incubation center on solar power. So that we are funding with 40 lakhs of rupees. And we are interested to fund more entrepreneurship or startup so that we want to change your mindset from becoming employee to become employer. I hope you understand the difference between becoming employee and becoming employer. You're not looking for a job, but you will have a company where you will be giving jobs to others in your startup. That's the mindset we are trying to work with. Even the Platinum Jubilee celebration, which we are planning for next year, we are going to have a lot of talks on this topic, how to change the mindset from becoming employee to employer. Any one of you are interested in that, we are ready to work with you. We are ready to work with faculty. And I'm working with Dr. Prakash uh, through BIT Alumni International, because I'm president of that also, and we are funding from there. So we are available for that also. Now, any question you have, anything related to you, Miss, it should be related to you. Anything, your question you want to ask, floor is open. And this is for faculty, student, alumni, anyone.
So one of the audience asked the question that, as you mentioned about aeroplanes being fueled by hydrogen fuels, so the question is that could there be any risk in that field that aeroplanes are fueled with hydrogen fuel? So could there be any risks regarding that?
The only way I can answer that, if we had all the safety measures the way we are trying to implement right now, then the gasoline fueled car may not have come in existence, because a lot of people were worried that gasoline will catch fire and this will happen and that will happen and all those things. So yes, risk is there, but they are also mitigated similarly as for fuel based aeroplane design, and those risks will be taken care accordingly. No doubt. And that's where we come, how as a chemical engineer we can reduce the risk. That's our job. But there was no accident in all the trials, and they have at least 300 trials already done by different companies. It's not just one company I'm talking. Next question.
So one of the student asked that, sir, how to cope up with the industries, the recession period that is going on, and maintain a positive mindset along with that?
I just answered. You should start looking around you what problem society or your village or your neighborhood they are facing or your country is facing. Try to solve that problem. Have your own company. You don't have to worry about recession. The recession comes to those people's mind frame who are looking to be just employed. I'm bringing this challenge to all the students and everyone that instead of getting employed, be employer, have your own company, change the mindset, work hard, be positive, and your company will succeed and employ many employees. Google was like that. Microsoft was like that. All these companies started, Apple, all these companies which you hear the name, they started with the same issue. What is the problem people are facing? And let's solve it and market it. Facebook, WhatsApp, all these companies, they did same thing. Meta, all they did solve the problem what we are, or make our life easier and make money.
Yes, sir. I believe that audience got the answer that they wanted to know from you.
Dr. Nirupma, any question from you?
Yes, sir. I want you to at least say these students like these days, mostly the student will be from first year and second year. So they are mostly confused, like what will they do in the chemical engineering? Mostly they are like conception, like they will go for some coding and computer thing. So these thing also they can do as a chemical engineers also. So in that field also, if you explain something to these students, that will be appreciated.
Perfect. So the question is that first year, second year students are confused that what they should do and what they should do in the sense that should they go in the core area of chemical engineering or go
Exactly.
in the computer side where they can good money and there are a lot of good name for IT and computer side, or they should go and have their own entrepreneurship and startup company. So this confusion is absolutely genuine, and basically every student comes with his own background. Like someone has to quickly and make money, or you may have to just grab the first job which you are offered. If you're just looking from that background, I will not tell you to go and have a startup, because your aim is to grab your first job and support your family. So in that case, you will be open for IT or chemical engineering or anything what you get. But what I'm looking at that if you look for a purpose, what are you here for? Why you selected chemical engineering? I'll give you my example. The reason I came to chemical engineering because chemistry was my favorite subject in high school. I loved chemistry. And the application of chemistry is chemical engineering. Just think about it. We have done so many projects, so many plants. What is the purpose of building those plants? What is the purpose of doing those projects? Is to give people livelihood, to make their life better, and make society happier. If you feel that your purpose is to make your surrounding better, definitely go to the core branch. And if you have time that you don't have to go and get the first job, look for a good company. As I mentioned, I help people for getting job and work with any, not with me, with anyone who can support you in getting job. Get a good job and do that. But I also mentioned that if you are a visionary and if you think that you can come up with the idea which can solve the problem of society, which was not considered before, become entrepreneur. And for them, the first year and second year is the best time. I think I'll say first year is even better. When you come to the college, you come with a dream. You look around. In fact, one of the criteria what we have that we will request the groups to visit surrounding areas, villages, or maybe some places where they can see that what problems the society is facing right now, which you can bring the solution through your startup. And if you're the visionary like that, go for startup and sky is the limit. In IT, you can go up to certain uh, position. When you are going the core branch, that broadens your spectrum. You can have your own chemical factory, work in the core plant, and I know several of them from my batch also who started his own industry and did very well. But if you want to go in entrepreneurship, sky is the limit. You know all the people who have a multi-billion portfolio in the world. So look at your background, get convinced what your family, your friends are telling you, what you want to do. You want to be a problem solver in the society. You want to make people having what they need in their life, or whichever way you want to do. All three options are for you. But I also mentioned that if you are in doubt which one you should take, I can have a consultation with you and explain to you that what is fit for you. Because if you are confused, take that necessary step. This is free appointment anyway. Talk to someone and get your clarity. When I was in BIT, the alumni were not available to us as they are available now. Now, if you want, you turn around, you will see 5 alumni are available to you, and you can talk to them and get clarity in your mind. That's the way to go. Did I answer, Dr. Nirupma?
Yes, sir. Thank you very much.
Any other question? People are speechless. They're not speaking anything.
No, sir. Most of the answers you just mention all the particular topics or the audience which were asked the question you mentioned all of them.
Okay. So if no more question, then time to end.
Okay, sir. Then, okay, you don't have any other question, right?
Uh, so I think audience have quenched their queries about the entrepreneurship, about green hydrogen, and everything that they wanted to ask from you and get a guidance about that. Now, moving on further to the session, will come on. Uh, Thank you, sir, for the insightful journey. Your knowledge was very significant for all the audience, and you talked about everything that questions were asked. You made the session so interactive that the audience felt it like talking to you person to person.
Thank you.
And now I would like
Now,
now I would like to invite our Professor Dr. Nirupama ma'am to deliver the vote of thanks to our eminent speaker. We anticipate valuable and inspirational words for this great pleasure of having this amazing webinar.
Okay, thank you. Good evening, one and all. On behalf of Department of Chemical Engineering, BIT Sindri, I want to express our heartfelt gratitude to Mr. Prafull Kumar, President of Dream Realized LLC, and he is also specialized in career counseling and leadership development. And and also, I appreciate how he has taken his time from his busy schedule. Your presentation, Pathways or to Net Zero Strategy Challenges and Innovations in Achieving Emissions Neutrality, seamlessly integrated theory and practical insights, making the lasting impact on our students. The increasing global industrialization and over exploitation of fossil fuels has induced the release of greenhouse gases, which is leading to the increase in global temperature and causing the environmental issues. So I appreciate the way you introduce and explain a roadmap for global energy sector is going to reach net zero emission by 2050. Uh, you also explain the strategies which can be used for this net zero, the concept we can utilize, how we can reduce the use of fossil fuel using some efficient processes and improve our energy efficiency using the new technologies. I appreciate the way you introduce new technologies also, which is going to come in near future, like nuclear fusion, green ammonia, and the future automated automobiles, which are going to use this fuel cell, which is also think they are using it. And also, you have covered the new and important area which a chemical engineer can opt and do their research and development. Your talk not only enhanced our intellectual pursuits but also ignited the inspiration for all of us. We deeply appreciate the time and effort you dedicated to preparing and delivering this lecture. Your expertise has made a significant contribution to our students and all the listeners. And we are thankful for the opportunity to learn from the professionals like you. Thank you for your generously sharing your wisdom, and we eagerly looking forward to the possibility of future engagements. Your lecture is much appreciated, sir. Thank you.
Thank you. I'm available anytime you need me. Just feel free to connect, and I'm ready to speak any topic related to chemical engineering. Thank you very much.
Okay, thank you so much, sir.
Thanks, ma'am, for such warm wishes. Prafull sir, it is truly an honor for us and our viewers that you shared your knowledge and expertise with us. We express our gratitude with a small token of appreciation by the Chemical Engineering Department of BIT Sindri and Team Quimica.
I'm honored. I'm honored. Thank you. Thank you very much. I feel
Thank you,
honored
sir.
and thank you.
Thank you so much, sir, for this amazing session. And we look forward for much future collaborations with you and have a fruitful talks with you.
Anytime, anyone, connect with me. I'll be happy to help as much as I can. Thank you. Thank you.
Special thanks to all professors and participants for engaging actively. We hope today's knowledge escapes curiosity and inspires industrial leadership. Have a wonderful day ahead. So, I would like to thank our audience as we are ending this live stream. Thank you for joining us today.
Yeah, appreciate the opportunity given to me. I really appreciate this. Thank you. Thank you. You did a wonderful, all of you, wonderful audience and organizers. Take care. Yeah. Bye.
Thank you, sir, and have a good day.
You too. You too. Bye.